Here's another example where we're going to find where the function's increasing, decreasing, and any local maxima and minima. To begin with, let's graph the following function. Negative x cubed plus 6x squared minus 9x minus 4. Okay. This graph is more complex than the previous example. Notice that if we begin to trace the graph from left to right, it drops to begin with, so it's decreasing. We have a valley, so we have a minimum. Then it rises, so it's increasing. We have a peak, we have a maximum, and then it drops again, so it's decreasing. To begin with, let's find the minimum. So we repeat the following calculator steps. Second, trace, minimum, enter. Left bound, your cursor should already be to the left of the minimum, so you can go ahead and press enter. Now you see right bound. Now move your cursor so that it's to the right hand side of the minimum. Once you've moved your cursor, enter. It'll say guess at the bottom of the screen. You can just enter. Then the minimum should appear. Okay, notice how my minimum gives me 0.9999 and so on. Y equals negative 8. Your x value may be a little different. You might have 1, you might have 1.001. This is because of where you place your cursor to the left and right. But if we all round our values to 3 decimal places, we should arrive at the same answer. So our minimum here, remember, is the y value, negative 8, at x equals 1. So we should all arrive at that if we round to 3 decimal places. Now that we've located the minimum, next let's find the maximum. To find the maximum, press second, trace. This time select the maximum key, which is number 4. Okay, then it'll say left bound. Make sure your cursor is to the left of the maximum. It already is, but you may want to move your cursor a little bit closer to the maximum, but keep it to the left hand side. Enter. Next, we have to find the right bound, so now move your cursor to the right hand side of the maximum. Once you have it to the right hand side, enter. Next, we have guess. You can go ahead and enter. Now we should have the maximum. X equals 2.99986. Again, you might have something a little different. You might have 3. You might have 3.0001. Y equals negative 4. Again, if we all round to 3 decimal places, the maximum should be negative 4 at x equals 3. So again, the minimum, negative 8 at x equals 1. The maximum, negative 4 at x equals 3. Now, we said to begin with that graph was falling, so it's decreasing. Okay, since we are starting from the left-hand side of the graph, we start with negative infinity. It decreases until we approach that minimum. The x value at that minimum is 1. So our first decreasing interval is negative infinity to 1. It passes through that minimum and it increases, so it's increasing from 1 until we approach the max. The x value at the max is 3. So it's increasing on the interval 1 to 3. It passes through that max and drops again, so it's decreasing again. It's decreasing from 3. We're now on the right hand side of the graph, so we end with positive infinity. The only thing left to find in the problem is the domain and range. Remember, domain, values for x, we could plug in any number that we wanted to for x, so the domain is all reals. Negative infinity, positive infinity. The range is also all reals. Notice how one end of the graph is going up, the other end is going down, and then the graph is just doing some turns there in the middle. When that happens, your range is also all real numbers, negative infinity, positive infinity. This completes the problem.